So in the previous video clip, we made the non-exact equation as exact. Okay, so now we have partial m over partial y and partial n over partial x, both are equal to each other. So for an exact equation, what do we do? From where do we start? We start from, since the equation is exact, so we start from the solution function. So we assume that the solution is f, okay, and its partial derivative with respect to x is equal to our n function, m function, which is xy power 4 over here, xy power 4. Okay, so from here we can find f by integrating it with respect to x. So it will be x square y power 4 over 2, okay, and then plus a function in y as a constant. Okay, next step, you take the partial derivative of this function f with respect to y, and then we get from here y power 4 will become 4y cubed, so x square 4y cubed over 2 and plus g prime derivative of g. Okay, so this will be then simplified to 2x square y cube plus g prime y. So now we have to compare it with the n function, which was the new n function. N function was, what is the n function? Yeah, this function is here. So we have to compare it with this. So it is y cube 2x square, y cube 2x square. Okay, so let's write in full function, full form without the parentheses. So this n function is 2x square y cube, 2x square y cube, and then it will be 3y power 5 plus 3y power 5, and then it is minus 20 y cube. So if we compare these two values, partial f over partial y and this n, so only the first term is common. So that means that if these two identities have to hold equal to each other, then that g prime y should be equal to 3y power 5 minus 20y cube. So this is a function in y, so from this we can get g of y by integrating it. So 3y power 5, that will become 3y power 6 over 6 minus 20y power 4 over 4. Okay, there is no need to add constant over here. So it will be 2y power 6. It will be y power 6 divided by 2 minus 5y power 4. So this is the gy. So therefore our solution will be x square y power 4 over 2 plus gy. Gy is y6, y power 6 over 2 minus 5y power 4 equal to a constant. We can further simplify it to make it like x2 y power 4 plus y power 6, that means we multiply it by 2 minus 10 y power 4 equal to a constant. Okay, so this will be the solution. Okay, let's solve another problem in which the equation is not exact. Okay, so the equation is cosine of x dx plus 1 plus 2 over y sin x dy. So in fact this equation is a separable equation, but we are not doing it by that method. So let's check this first, whether that equation is an exact equation or not. So if it is m and then that is n, then partial m over partial y is 0, and partial n over partial x is 1 plus 2 over y into cosine of x. So since these are not equal, so this is not an exact equation. So what we are going to do is now we want to find the some integrating factor. So for this let's say I try some function for integrating factor p. So that p function will be equal to 1 over n. N is this 1 plus 2 over y sine of x multiplied by partial m over partial y 0 minus partial n over partial x 1 plus 2 over y sine of x. So it is, since it is 0, and you can see that 1 plus 2 over y cancels with 1 plus 2 over y, so minus cosine x over sine x, that is minus cotangent of x. So from this we can use this minus cotangent of x to find the integrating factor mu, which is the exponent integral minus cotangent x dx. So we know that for minus cotangent x, since it is cosine x over sine x, cosine x is in the denominator, so its integral will be, and its derivative is in the numerator, sine x. So its integral will be log of sine x. So it will be exponent minus log of sine x. Okay, and then we can represent it like this. Minus we can take inside of the log, so it will be 1 over sine x. Okay, sine x power minus 1. So now exponent and log cancel off with each other, so we are left with 1 over sine x or cosecant x, whatever. Okay, so we can use this in multiplication factor, integrating factor 1 over sine x, and then our new equation becomes, when we multiply it with 1 over sine x, so it becomes cosine x over sine x, it is cotangent x dx, and then 1 plus 2 over y sine x over sine x, so it will be cancel out, so it will be, so this is the new equation. So now this new equation should be an exact equation. So if it is m, it is n, so partial m over partial y 0, partial n over partial x is also 0, because this is an x, this is a function in x, so we are taking derivative with respect to y. So both are zeros. This is an exact equation. So the solution of this exact equation will be a function f whose partial derivative with respect to x will be equal to cotangent of x. Cotangent of x. So in this case, then f will be equal to integral of cotangent of x. Integral of cotangent of x is same as like we did here. It will be log of sine x, okay, and then plus constant gy. Now we take partial f over partial y, so it will be 0, and then it will be g prime of y. So this g prime of y should be, this partial f over partial y should be equal to this value 1 plus 2 over y. So from here we can find g of y by taking the integral of this with respect to y. So it will be y plus 2 over y, so it will be log of y. So it will be y plus log of, and you can take 2 inside, so it will become log of y square. So in the end we get the solution which is equal to log of sine x plus gy. Gy is equal to y plus log of y square is equal to constant. So this is the solution.